In this video, we want to show you sort of the first background information and a couple of examples on titration curves. As I record this video, we've been talking in class lately about titrations and in large group class as well about the idea behind titrations in terms of what it's doing. In first year chemistry, titrations are basically for neutralizing an acid with a base or a base with an acid, and how we make measurements of volume and known molarity to determine the molarity of the other substance. So if we know about the acid, we can determine the molarity of the base and vice versa. But with this today, we want to show you a titration curve. And so a titration curve is something that you collect data for and then draw, or in this case, we're going to have the computer collect this data, and then we're going to draw it sort of freehand on this page that you've hopefully picked up. And if you don't have one, you can draw this out on any graph paper, really any sort of notebook paper would work just for a crude one. And as we draw it toward the end, I'll point out some of the things that you want to make sure to include in your picture. They're mentioned on here as well. Some important things to remember about drawing titration curves. So I won't read through all these. If you have this page, that's obviously right in front of you. And if you don't have this page, you can pause the video and read through these things. But we'll go through. I'm just going to show you how we collect data for this using probeware today. And it makes our lives a lot simpler when we do it with a computer and some pH probes like you're about to see. So what I've got here set up is a small titration space, and I've got it hooked up to my graphical analysis software. So we're going to collect data from the beaker that you see here. And in this beaker is a solution of vinegar. So this is vinegar solution like you've titrated this year in lab already. And if you're watching this in a different year and you haven't seen this yet, then maybe you aren't as familiar with it. But in this beaker is a small sample of vinegar. And then also in here a little bit of extra water just to make sure that there's enough liquid in here for the pH probe to reach in there. So this is the pH probe, this kind of blue wand. And down there in the tip is an electrode that measures pH. And then there's also a little white stirring bar magnet in there. And you'll see here it's resting on this stir plate. Of course, if we turn it on, it's going to spin that little white magnet. Okay. And that mixes our solution continuously and keeps everything well blended instead of us having to do it by hand. It also splatters a little bit and makes a bit of a mess, which is kind of a bad thing, but it is what it is. And I won't turn it on right away because it makes some noise and it's going to be irritating and you won't be able to hear me very well if I have that running. But I will run it when we actually do the titration. The other things you'll see here, I'm going to try to tip up just a little bit. What you'll notice here is that there's a burette tip coming down here. So this is our burette. And you've perhaps worked with burettes in the past, and there's our base in that burette. If you can see on that little green label there, it's got the molarity. Our molarity of this sample is 0.5080 moles per liter of sodium hydroxide. So there's our setup. And then this last piece, this gray deal right here, is a drop counter. And what that does is it counts the number of drops that fall from this burette through this little space right here. And it acts kind of like a security little light, a laser sort of thing on your garage door might, where it's a photo gate. So there's a little light passing through this space from one side to the other. I don't know which way it's going, but through this open space. And when something passes through there, it counts that. Okay? That's the idea. So it's going to count how many drops fall through that space, and then the computer has a way to turn that number of drops into the number of milliliters of solution that are being dispensed from the burette. So we don't actually even have to measure the numbers on our burette. We just make measurements by letting this count the number of drops and convert that into milliliters. So I'm going to start the titration real quick. And what I'll do is turn the software on. You see on the screen here we've got our graphical analysis software ready to roll. It's got pH on the y-axis. It's got volume on the x-axis. I doubt you can read it, but down here in the corner it's really small. It's telling me that the current pH of the solution is about 2.86. So it's an acid, not real strong, but that's vinegar, so that sounds about right. When I start this, you'll notice that every time a drop passes through that little drop counter, it's going to record a point on the graph. And as it drops several hundred drops, it'll record a point each time and draw in a hopefully very nice titration curve that we'll talk about when it's all done. I've also put in here, I forgot to mention in the beaker, a couple drops of that indicator that we used in lab. So there will be a little bit of phenolphthalein in here that'll change color when we finally hit our endpoint and when the pH changes. What I want you to be looking for on the graph is when the curve spikes up suddenly. It's gonna be plotting points across here, and when the pH changes suddenly at the end of our titration, you'll see a couple things. On the graph, you'll see the slope of our curve change dramatically in just a few drops of solution. And you'll also hopefully see in the beaker at that same time the color change of the solution. So we're kind of looking for two things to happen at once and very independent of each other, but for the same reason. So when the pH changes in the solution, the indicator will change color here in the beaker, and you'll also see on the graph the pH suddenly changing, and hopefully those things will coincide. I didn't try it beforehand, so I guess we'll find out if I'm gambling or if I get good luck. So I'm going to turn this on. We got to start collecting first. So click collect up there, and it's ready to go. It doesn't actually start collecting any data until the first drop comes through. I'm going to turn this on, and it's going to be a little clattery because the magnet makes a lot of noise, but I'll let that do that. And I'm going to let the drops fall, and I'm just going to let you watch it for a little bit. I won't try to talk over that spinner because you won't be able to hear me very well, but keep an eye on what the data does. And then as far as when we're done, you'll be drawing out the curve that's finished. When this graph is all done, it'll be done, and I'll tell you when we're finished, we'll stop collecting data. That's when you want to draw it and put it on your sheet. So don't try to keep up with it, just keep an eye on it. And if you're watching this on video, then you can fast forward a bit through the drops till we get to the end of the titration and the color changes and our pH changes real fast. So let me get this started and you can take a look. Well, I'm going to stop this and wrap it up. All right, so hopefully you can see here that, I mean, a lot of things have happened since I was talking to you last. We've got a lot of data on our graph. I had a little goof at the beginning, so we'll just kind of disregard these first couple dots. But the curve shows the pH very gradually increasing here up until we get to somewhere in that 15 to 16 milliliters having been added down here on our x-axis. And then suddenly that pH starts to change really dramatically. We've also got, obviously, color change in our beaker. So at some point in here, that color change occurred. And we'll go back, and you can slide back the video, obviously, and take a peek at it and try to see if this color change, which came about rather suddenly, corresponds like it should with the sudden increase in pH on this graph. And I'll be honest, I looked away for a minute. I missed the moment when it changed, so I'm not sure which of those drops caused it, but I'm going to go back and look at the video too. So I've got the drops shut off. I'm going to stop collecting data on my graph. And so I've got this nice curve. Here's what I want you to do. I'm going to close up the video or minimize my video here for a minute and go back to our graph. Here's what I want you to do. On this page or on another page of graph paper, if you don't have this page, we kind of want to sketch out approximately the same curve that you see here. Okay, so this is our titration curve. And again, the notes on this page will kind of remind you of the things that you want to do. One, we want to make sure we've got the axes set up right. So make sure you've got the pH on the y-axis and your volume on the x-axis. In this case, it says here volume of acid or base. We're adding the NaOH. So your graph here would be volume of NaOH that you've added in milliliters. Make sure to start your curve at the correct initial pH. All right, so initial pH on our graph here, go back to it, right around 3, a little bit higher than 3 the way it ended up because my first couple drops got an error in them, but we'll start right about here. Honestly, that starting pH doesn't mean as much to us in chemistry as it would in like an AP chemistry situation. In the end, we're really looking for that moment where the pH suddenly changes as the information that we're going to need in our math. So try to start your pH down here in that 3 or 3.5 range. Looks like the very first data on our graph put a pH at approximately 3.4, so something like that. We want to make sure that your titration curve has approximately the same shape as what I've got here on the screen. So in other words, we kind of want it to start out low, kind of gradually have a little slope to it here that's very consistent, and then at the end this kind of a quicker curve that spikes up real fast. Okay. We want to make sure your end point, it says here on the instructions, the end point or the equivalence point is at the right place. Okay. And so on your graph, the place where your curve suddenly rises quickly should be here somewhere approximately, let's pick a point out here, about 15.4 milliliters is kind of what we're looking for. So somewhere around that 15.4 or 15.5 milliliters is where we want that pH to spike as you doodle this out. And again, this is just kind of a rough sketch so you have one in your notes. And that the pH at that moment is somewhere in that 8.5 to 9 range. So depending on which one of these points we use, we might find the pH is changing anywhere from, see here, 9.7, 8.5. It's changing very quickly in just a few drops. And this is that moment that we're interested in as far as doing the math, okay, of our calculations for the titration. And then at the end, you should always try to let it go off. Notice what I let it drip for quite a while past the color change because we want to have some of the titration curve sort of leveling off. So we had it continue for a while. The pH levels off again. And it leveled off. The last data that I collected up here sits around 13, so a pH of about 13. So take a minute, and if you need to pause me, but take a minute to take a look at your curve and see if you can make it look approximately like this curve. And then we'll come back together and do the math on it from there. But take a little time, get your graph drawn, and I'll pick it up with you from that point. All right, so for the next part of our work with this data then, we need to take the graph, and I've cheated a little bit because I just took the graph from my sensor and I plopped it in here to be able to work with it. So yours won't look quite as snazzy as this. Maybe yours might look better, I don't know. But what we want to do is have the graph that you've drawn, And we want to be able to take from it the data we need to do the calculations that are ahead of us now. And so take a look at your graph, and this is the original, so you can kind of compare yours to the original. What we want to look for, first of all, is this area right here where the pH changed really quickly with just a few drops. Notice from here to here, right? The pH changed dramatically in 1, 2, 3, 4, 5 drops. For all these drops down in here, we had hardly any change in pH at all. And then all of a sudden, over the course of 5 drops, the pH went up, from 7-ish up to like closer to 11. The pH changed with every drop. It was changing dramatically. And so that's the part we're interested in. And specifically, what we want to do is we want to look for the middle of that steep area. So I'm just going to kind of darken the steep area in here just a little bit. Something like that, so it's continuous. You may have done yours as a continuous line. You may have done yours as dots. Either one is okay. But what we want to do is we want to choose the point kind of right in the middle of that steepest curve. Now, this is a little bit of an eyeball thing where you just kind of have to pick. And I'm going to pick kind of right about there, okay? This area right in here as my middle of my steep area of the curve. And again, that steep area runs, from here kind of down to here. So kind of right in the center of that is the sweet spot we want to look for. And the number that we want to take from that then is, based on what we've got, we want to be able to take that down from that point to the volume that it corresponds with. All right. So if I take my point and extend it down to the bottom of my page, let's see here, I'm grabbing a marker. That corresponds to approximately right in here. Okay. How many milliliters? And on yours, it may be slightly different. I'm going to try to finish out my graph a little bit. I don't have very many marks here. So this looks like 15. This looks like, to me, 15.5 milliliters. And we're going to go with that and just take it from there. So hopefully, as you look at your graph and as you look at mine, you'd agree that the middle of that steep slope on our curve is around 15.5 milliliters. And that's 15.5 milliliters of NaOH that were added when we hit that ending point. Okay, 15.5 milliliters of NaOH were used, and that molarity was again 0.5080 moles per liter NaOH. So that's our important information to do the math with from there. All right. Now, let's go back over and do our calculation with this one and kind of wrap things up. As we do with our titration calculations, we need to start with a volume of the known. And so that's this value that we just dug off of our graph. 15.5 milliliters of NaOH were needed. That NaOH had a concentration of 0.5080 moles per liter, or per 1,000 milliliters, which we can use here since that's our starting unit, right? And we want our units to cancel out. And then this was NaOH as our base along with the acid, which was vinegar. And so NaOH plus acetic acid or vinegar would look like this. Remember, as we look at our equation, it's not even as important that we finish the whole equation as much as it's a matter of this base has one hydroxide group in it, and this acid has one important usable hydrogen in it. So one OH, oops, pardon me, computer went on its own. Okay. One OH group and one hydrogen, it means that these are in a 1-to-1 ratio. Right? Our acid and base will combine in a 1-to-1 ratio because this OH and this H come together to make water, right? And so our 1-to-1 ratio means in our graph, there's going to be 1 mole of acid neutralized for every 1 mole of base that you added. Now, we didn't use anywhere near a mole of acid or base, but that's our 1-to-1 ratio. And I can calculate this, cancel things out here, everything cancels out. Right? And then we can do our calculation to figure out what that answer is going to be. So take a second with your calculator and punch it in. See what you come up with. Okay? We're going to take 15.5 divided by, or rather times 0.5080 divided by 1,000, and then times 1 divided by 1 essentially. We get 0.00787 moles of acid, of vinegar. Right? So that's just out of the calculation. And now we're not quite done. We need to finally, and hopefully you remember this from our titration math, we need to find the molarity of the acid. And so we need moles over how many liters did we use. Right? So when we went to get our sample of vinegar, how much vinegar did I put in that beaker before we started? That's the question that we need to include here. Pardon me. All right. So for this particular titration, we used, man, bad clearing of my throat. We used 10.7 milliliters of the original acid. And so I'm going to do that in liters, 0.0107 liters. Divide by 1,000, and we're off and running. What's that overall molarity going to be? So 0.0787 divided by 0.0107. And we get a molarity of 0.736 moles per liter. That's our molarity. You could also write it as 0.736 capital M. And then it's our acid, so let's go ahead and label it as C2H3O2. There's our acid answer. Okay. So we took our data, we put our titration set up together. We collected our data using pH here and drops, which were then calculated as a volume that we added. We collected data, hundreds of data points here to make this nice curve. We looked for the moment when the reaction was finished, when all of the acid had been neutralized. So up until this point, all the way through here, there was still some acid left over, some acid left or remaining in the beaker, right? But then when we get to the end and all the acid is neutralized and there's no more acid left, there's nothing to keep the pH of our solution low, because all the acid's been consumed by this base that we've been adding. And so suddenly the pH rises very dramatically through that point when it's neutralized. And there's that special moment when it's been neutralized. And we call that again the equivalence point, or the end point, because it's the end of our titration. So that's our neutralized solution. And then up here, we've got a region where the pH is very high, because what's in the beaker at that point? All the extra base that we keep dripping in there. So the extra base equals a high pH. So that's kind of why this curve is the shape that it is. Low pH when there's acid in the beaker, a neutralized solution when we pass through that kind of middle point, and then at the end, a very high pH in our solution because we keep adding more base to it and the pH just gets really high. So there's kind of those three stages of the titration here. And the moment that we're most interested in is when is that solution sort of quote unquote perfectly neutralized. And so we're looking for that steep moment in the middle of our curve. We picked it out. We did our calculations from there. And that's the volume then at which we would expect the color change to have happened and the pH to have suddenly changed because the acid had all been neutralized. That's how we use a titration curve to calculate the pH of an unknown, rather than having to look for a color change and having nothing to go on but a color change. We watch for a sudden dramatic graphical change that in this case accompanied a color change. And hopefully that worked out for you and the calculations made some sense. If you're stuck on this or you're not quite sure how we work these numbers, let me know, but at least have had this graph doodled out, okay? And then in class, either in class or on another video, we'll show you a titration where we start with a base and work our way towards an acid instead, all right? Until I talk to you again, thanks for watching, and I'll see you next time.